Maybe Taylor series. Why not the pre-class that was due today? That one isn't a cosine or a sine function.
So, ooh, I know how to spell. Okay. So to review session. Okay, so you said anything about Taylor series?
I said the pre-class for today because it isn't a cosine or a sine function. It's a natural log. It's different than what was went over in class.
So it's like if we just have f of x is equal to natural log of x and a is equal to 2. Does that work?
Sure.
Cool. All right. So definition of the Taylor series is equal to f of x and sum of n is equal to 0 to infinity f n a over n factorial and x minus a to the n. So probably do like the first 3 terms just because it gets pretty repetitive after that. So f of x is equal to natural log of x. Then f prime of x is equal to 1 over x. Equal to x to negative 1. F del prime of x is equal to bring down the variable and subtract 1. No, wait, yes. And then f triple prime of x is equal to 2x to the negative 3rd. All right. So then since we're doing third term and a is equal to 2, don't be f of 2 plus f prime of 2 over 1 factorial times x minus 2 plus f double prime of 2 over 2 factorial times x minus 2 squared plus f triple prime of 2 over 3 factorial times x minus 2 cubed. So f of 2 is plugging into here, so it's natural log of 2 plus here we're plugging into here, so it's 1/2 times 1 factorial is just 1, just x minus 2 plus, and then plug in here, so this is equivalent to negative 1 over x squared. So that's negative 1/4 times 2, 2 factorial, times x minus 2 squared plus that's going to be 2 over 8 over 6, because 3 factorial is 6. And x minus 2 cubed. And then from here, it'd be simplifying these terms, so I end up with this would be -1/8. And this would be 1/24. And then let's see here. Yeah, that all we have to do with Taylor series. Oh,
The general term.
yeah. Okay. Yeah. So you see, so the first one is kind of different from the rest. So I think generally you want to do natural log of 2 plus the sum of the general term, right? Keaton?
Plus some of the term.
Yeah, because so
Yeah.
yeah. And so then you have
Yeah.
you have x minus 2, and so here you'd start at n is equal to 1, infinity. So then you have x minus 2 to the n, and then
I believe there are some cases in the web assign where people have had to write out some beforehand. So
yeah,
I think that works.
and you're going 2 to 8 to 24, which is a pattern.
It's a factorial.
Oh, yeah, well, I guess you can just keep, in this case, it'd still be n factorial and then times by 2n, is that right?
Yeah, I think it is the negative one or something.
Would be 1. Oh, no, it wouldn't, it'd be, yeah. The n, yeah, n to,
It'd be 2, right?
yes, it would,
Yeah.
2 to the n minus 1, right? Because you start at n is equal to 1.
Well, our first term is 1/2, right?
It is 1/2.
So we're good at this.
Yeah, I am awake. And then also you see there's a negative here. So it goes positive, negative, positive. So you also want -1 to the n in there. So that's just kind of breaking up each of the things. So then your general term would be x minus 2 to the n over n factorial. And then if you wanted, you could write -1/2 to the n. Or you can just leave it like this. That makes sense.
Yes.
Cool. Yeah. Yeah, so like with this one, if you have the first term doesn't match the rest, you just write it out in front. Is there another one you want to go over, or
Anything on the web assign that was due tonight?
do you have
That was a power series.
Okay, so going back to 11.8.
Yes. Anything in there is good. Or anything like it.
So then you had to find the radius and interval of convergence, correct?
Yep.
So if you have this one's fun. You have sum of x to the n over n to the fourth of 4 to the n. And you go to 1 to infinity. So then you can do a ratio test on this. Then you have x to the n plus 1, or n plus 1 to the fourth times 4n plus 1 all over x to the n over n to the fourth, 4 to the n. So just rewriting that, you can write as x to the n plus 1 as x times x to the n. Or n plus 1 to the fourth times, again, 4 times 4 to the n, and times by flipping this and get n to the fourth times 4 to the n over x to the n. And these cancel out, and then I guess technically we have lim. Then goes to infinity. Then you're left with the lim as n goes to infinity of x n to the fourth over n plus 1 to the fourth times 4. So with this, you can either see that it's like you
Is it
can
1/4?
yeah, or well, it'd be, so you have x over 4. So yeah, so you can look at this as n to the fourth over n plus 1 to the fourth, and this would be infinity over infinity. So looking at in the simpler way, you can just cancel those out. So then you have x over 4 must be less than or equal to 1, or less than 1, not less than or equal to. So this is absolute value. So that means the absolute value of x must be less than 4.
So what's stopping me from looking at that limit and seeing the n to the fourth and then seeing n plus 1 to the fourth, seeing that n to the fourth are the same, so it's just a constant, which is 4 on the bottom, so it's 1/4.
So like you're saying just right, or like I guess
Or is it because the x is still there technically?
the x is still there because you have
Okay, then it's the same anyways.
yeah, so because what you're trying to solve for is which value of x does this converge.
Okay.
And so then the x stays in there, and so then you can tell that when the absolute value of x is less than 4, this series will converge. And so then the interval would be, since this is absolute value, it'd be x goes from -4 to 4. So that'd be the interval, which
And the radius would be 4.
yeah. This is the radius, and then this would be the interval, which, so then I think in web assign, typically they'd want you to like put in like that, I think.
Yes.
You have an example?
You're going to assume or parentheses rather than brackets,
Yeah.
because typically at the ends of the interval, it's not going to converge. It's iffy on the negative side.
Is there a question from WebAssign you'd specifically like to go over, or?
Not really.
Yeah. So did you say that there was a WebAssign that you wanted to go over, or no?
Oh, no, there wasn't a particular one.
Okay. I think. Guess I can do just. So we have infinity is equal to 1 of n factorial 2x minus 1 to the n. Again, I need you to limit n goes to infinity of n plus 1 factorial 2x minus 1 to the n plus 1 over n factorial times 2x minus 1 to the n. That doesn't seem right. I guess you have n plus 1 times 2x minus 1 times 2x minus 1 to the n. I forgot n factorial in there, and then n factorial x minus 1 to the n. These would cancel out. Move the limb and goes to infinity. So root value of n plus 1 times 2x minus 1. as you can see, if you just plug in n is equal to infinity, so you get the limit would still be infinity. So then your radius would be 0 because it'd be 0 because no matter what you do plug in for x, this will always diverge.
Yes.
Yeah. I was trying to pick one that was gonna have a weird interval. I guess.
It's always hard coming up with examples.
Yeah. They never do what you want them to do.
It takes a lot of experience to make examples on the fly.
Well, I'm
Or
looking at
that's
the
probably
book.
what-
Yeah. No, I wouldn't even try to
It
do
also
it.
takes a lot of experience to just tell what the answer is gonna look like. Right away.
Yeah.
If you don't have the key in front of you.
Okay, so then limit n goes to infinity without absolute value of 5x minus 4 to the n plus 1 over n plus 1 to the third. Then I'm just going to flip it here. 5x minus 4 to the n. And these cancel out, giving you the limit as n goes to infinity of n to the third and 5x minus 4 over n plus 1 to the third. And again, these end up with infinity over infinity. So then you end up with limit and approaches infinity of the absolute value 5x minus 1. Then the absolute value of 5x minus 1 has to be less than 1. So then what's and you should divide by 5 first.
I always add first after splitting it up.
Is that the way? I knew there's one way. Wait.
Technically,
Then
either way works, but
you end up with
yeah, you get rid of
1 is less than 1. Oh, that's negative 1. So
and then the 5x.
yeah.
That's how I do it.
5x minus 1. Yeah, that makes more sense. Okay, yeah. So you break it out of the absolute value first. Then you add 1 to everything. Then you have 0 is less than 5x is less than 2. And you should divide by 5. So from this, you can see that r should be 1/5. That's always 1 over whatever x is multiplied by. And you get 0 less than or equal to x, or less than x, which is less than 2/5. Yeah.
Yeah, you fall into a trap if you decide to divide first because you don't have that other side yet. And so when you deal without 1, it becomes 1/5 inside of the absolute value. You have to split it up again.
Yeah. All right. Yeah. So you get the same answer either way, actually. Okay. So yeah. So then in this one, we'll convert it to 0 to 2/5, and r is equal to 1/5. Does that make sense? Is that pretty straightforward?
Yes.
All right. So you don't have any questions?
in particular. Maybe more. Try some more just Taylor series stuff, especially finding the general term. Like looking at a series and trying to figure out what's happening to it.
You said not sine or cosine?
Those were done in class.
Okay.
Or those really the only two that really need to like seriously worry about.
I think sine and cosine are more popular because those ones alternate a lot better.
Let's see what WebAssign has.
Cosine, cosine.
WebAssigns. Let's just do 8 over x. A equals -4. It's probably easy, but it's not cosine or sine.
Said 8 over x.
Yeah, and a equals -4.
All right. All right, so I was just like writing the definition up top because at least for me, it makes it a little easier to just plug in everything. Infinity equal to 0. And up A factorial minus A to the n. I might do to the n is equal to 4 this time, just so there's a little more room to see a pattern. So if a is equal to -4, then, well, I guess so. You have f of x is equal to 8 over x. It's equivalent to 8x of -1. And f prime of x is equal to -8x of -2. F double prime of x is equal to -16x to the -3rd. F triple prime equal to -48 x to the -4th. And F fourth derivative equal to -192. Yeah, 192 x to the -5th. Fourth power or fourth derivative might be excessive, but I guess it's just more practice. Then you have start with f of -4. Then you do f prime of -4, 1 factorial times x plus 4 plus f double prime of -4 over 2 factorial times x plus 4 squared plus f triple prime -4 over 3 factorial. X plus 4 to the 3rd and plus f4 to the -4. 4 factorial times x plus 4 to the 4th. Okay. So then f of -4 is just -2 plus that'd be -8 over 16, so that'd be -1/2, or no, positive Yeah, -1/2. And then times x plus 4. 1/2 times, and this would be -4 to the -3rd, so it'd be negative, negative, positive. And then 4 to the 3rd is 16 times 4. The 16 we cancel out. So then you end up with times 1/4 times x plus 4 squared. And then that was a plus there. And then you end up with, I believe it's going to be -1/6. And because here you have a 4th power, so the negative would be positive, and 48. So 4 to the 4th is 16 times 16. 16, 3, 16 over, that's not right. 48, oops, 48 over 16 times 16, which is 3 times 16 over 16 times 16. That should be 3 over 16. There we go. 3 over 16. Then x plus 4 to the 3rd. Just making sure I have everything. Okay. And plus 1/24, because 4 factorial is 4 times 6. Now this one I need a calculator. 192 over 4 to the 5th. Okay. Oh, that's should be 3 over 16. Okay. Yeah. Yeah. 3 over 16 times x plus 4 to the 5th. Then you have x plus 4 to the n, that's not a 4. X plus 4 to the n, because you have that in every term. And then I'd probably, just because if you notice, each of these alternate plus minus except the first term. So just to keep it simple, I'd probably, again, throw the -2 out front. So that means in this case, n is starting at 1. And also, since it's alternating, you're going to want in -1 to the n. And since it's starting at negative, you do want -1 to the n, because n to the first is -1. And then looking at the rest, it goes 1/2, 1/8, 1 over 16 times 2, so 32, plus 24 times 2, so 48. That's not right. 24, 8 times 16. So that'd be 80 plus 40. I'm not blanking on how to do math. 8. 128. There we go. All right. So this is 1, 2, 3, and 4.
Like that.
Yeah,
See, I don't like combining things because if you combine things, it makes it harder to find a pattern.
well, so I wasn't gonna combine it, but then this one's 3/16, and then this one's 3/16 again. So you can't find a pattern just based off the coefficients. I definitely feel like there is one, but I'm blanking
Oh
on
wait,
it.
that's just multiplying the 4 every time. 32 times 4.
Yeah, so then it'd be,
Start at 2, multiply by 4 each time.
4 times, or no, it'd be 2 times 1/4n.
And 2 times 4 is negative. But we also have don't have negatives in there. So it's also in there.
Well, I already got that.
Oh, we already got that.
Yeah. Yeah, so this one's a little finicky. So we're trying, so if you have 2, so you saw it's multiplied by 4 every time. So that means you're gonna have some sort of 1/4. And I'm gonna do 1/4. 1/4 to the n. And then just to make it fit with the first term, we see, hey, if we start with 2, then it'd be 2 times 1/4, which would be 1/2, and 2 times 1/16, which would be 1/8. So we can see just throwing a 2 out in front matches each of the patterns. So yeah, it's
Also, this note when you here work line, make sure that your -1 to the end is starting on the proper sign.
yeah,
In
which
this
I
case
think
we are already, because n equals 1, so we start at negative,
yeah,
which after the -2, we go to -1/2. So
which I think in this one that we had done earlier, I think this one's actually supposed to be +1 because we start off positive and then go negative.
yeah, you can choose to either add 1 or subtract 1, whichever floats your boat. It doesn't really change anything overall.
Yeah. But yeah, so that's something I missed on this one was since you start at n is equal to 1 in this one, we start positive, so that means this has to be positive, so that means your power has to be even, so you can either add 1 or subtract 1. So I'm barely showing screen. Does that make sense? That
Yes.
okay, cool. And did this problem make sense too, or is that kind of jumbled?
Is it because you moved it 1 forward in your general term? Did n equals 1, so you had to do that. Oh wait, no, I'm confusing myself.
So like what I just, so here I'm just looking at each of these terms. And so then I just write them out and then I look for a pattern between each of them. And so each time the denominator is multiplied by 4. So that means you need some sort of 1/4 to the n to satisfy that.
Oh,
pattern.
okay.
Oh, sorry. And then from there, I saw that, oh, I need a 1/4 to the n. But if I just plug that in, then my first term would be 1/4, which it isn't. So then if you multiply it by 2, which is how I got that 2 right there, then it'd be 2 times 1/4, which is 1/2. And then just to double check with the second one, 2 times 1/4 squared is 2/16, which is equal to 1/8. So it matches the second one. And if we want on, it should match the rest of them too.
Okay.
Does that make sense?
Yeah, it does.
feel like that one does combine a lot of things you have to pay attention to, like the 1 minus or negative 1 to the n. So yeah,
These Taylor series, these seem very complicated.
yeah, it involves a lot of knowing when to simplify and when to not. Like this one, we didn't simplify the n factorial, and I'm kind of nervous about what we wrote here because I feel like if we no, this one, yeah, if we went to the 4th power, it may have changed what our equation is. But this one, since I went to the 4th power, I saw that. So like went from 1/2 to 1/4 to 3/16, and then like so this, where is it? So each time I was writing this term out, and so like here it didn't switch from 3/16, it stayed at 3/16. And so then I knew I couldn't just leave the 1 over n factorial in there, because at least I don't know of a pattern that goes 1/2 to 1/4 to 3/16, then stays at 3/16. So yeah, that's just a pattern I notice when I'm doing things. Like if things don't follow a specific pattern, then it's you generally want to combine them and look for the pattern between this term and this term divided out.
It looks like on the exam, they ask questions about Taylor series, but they give you a Taylor series for like a similar function, except the one that they want you to do is slightly altered. So you have to alter the Taylor series to match. Like they'll give you like e to the x, and they'll give you what that Taylor series is, but you have to take into consideration that x cubed is in front of that and know how that
Yeah.
relationship works. But
Yeah.
then they throw a natural log of x at you with nothing.
Yeah. So it's yeah, they might do like, oh, that's a good one. Like if they wrote e to the 3x, then you'd have to take into account when you're doing the derivative, you're multiplying by 3 each time. So then when you're looking at the specific series, which I guess that gets into, almost Maclaurin series, I feel like. I don't think you got into yet, or have you gotten into Maclaurin series?
I don't think so.
Yeah. But like eventually they'll, oh, where did it go? Like there'll be this, there's this table of Maclaurin series where it's one, like I think they tell you, it's like you'd look at this e to the x, and so you know it's 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial. But then if you have like e to the 3x, first of all, this like you can just see that each time the 3 gets multiplied out, so then you'd have to include like that'd be 3 to the n inside of this formula. So then it'd be,
I see, yeah. Oh, and they have the natural log down there too.
yeah.
That would have been helpful
Yeah.
this morning.
But Yeah, it's like, so you start with the Taylor series to kind of introduce you to the idea of the series and then how to solve for them. And then with Maclaurin, it's generally they give it to you and then you figure out how to manipulate it to fit with like a specific part of that equation. Guess we have about 7 minutes left before we have to switch over. Is there like another one you want to go over?
Not really, you covered most of the question. Really on the top. If you want to call it there, it's fine.
All right, yeah, I guess if you don't have any questions, we can call it a review session. Thanks for coming and
Yeah, thank you.
asking questions.
I didn't really ask any questions.
You guided towards what you were kind of interested in knowing.